Hello friends, Namaskar. Welcome to Dr.RAjeshverma's YouTube channel, and in this particular video I'll be talking about a very important and a basic statistical technique called as a quartile deviation. So before proceeding on the quartile deviation, now let us understand the meaning of quartile. What is quartile? One of the 3 points that divide a data set into 4 equal parts. So it's a very important here. Or the values that divide data into quarters. And each group contains equal number of observations or data. And importantly, in quartile, calculating the quartile deviation, the median acts as a base, and it's a very important one. So now this is the what I want to say about the meaning of the quartile. Now there is in front of you a figure. If you take a small scale or a wooden bar, and if you want to make the 4 pieces of that wooden bar, at how many places you are going to put cuts? To make 4 pieces, you have to cut it at 3 places. So there are 3 locations. These 3 locations are known as the quartile points, as it is visible here. So this is the first location, this is the second location, this is the third location. Oh, there are 3 points. So these are the quartiles. This is the first one is the quartile 1. Second one is the quartile 2. And the third one is the quartile 3. So you must able to differentiate between quartile and a quarter. So this is the first quarter, blue one. A green one is the second quarter, this is the orange the third, and this light blue is the fourth quarter. Whereas this line is the quartile 1, this is the quartile 2, and this is quartile 3. So this is all about the meaning of the quartile. Quartile 2 acts as the median of the data. This means this side, lower side, it contains the data set contains the 50% of the data, and at the upper side also there is a 50% of the data. Quartile 1 is the median of the lower 50% of the data, whereas quartile 3 is the median of the upper 50% data. So this is all about the meaning of the quartile. Sorry. Now, what is quartile deviation? It's a very simple one. The quartile deviation is half of the difference between the first quartile and the third quartile. You know, I told you the 3 points, Q1, Q2 and Q3. So the difference between the Q3 and Q1, and you halve that difference, that is your quartile deviation. This is a very simplest, and this is also known as the quartile coefficient of the dispersion. And you know, quartile deviation is one of the important measure of the variability, dispersion or spread of the data. So this is the formula. It is generally represented by the Q or QD. So QD is simplest one, Q3 minus Q1 divided by 2, or half of the difference of the quartile 3 and quartile 1. So as per the American Psychological Association, the definition of quartile deviation is a measure of dispersion that is defined as the value halfway between the first and the third quartiles. See, again I am reminding you, I am not telling about quarters. I am talking about the quartiles. So you must able to differentiate between quartile and quarter. That is half the interquartile range. You know what is interquartile range? Interquartile range is Q3 minus Q1 is the interquartile range. If we divide that range in 2 equal parts, it becomes quartile deviation, or it is also called the semi-interquartile range. So you do not have to confuse it. I'll revise and repeat once again. So quartile, 3 points, and what is quartile? Interquartile range, Q3 minus Q1 will be interquartile range. What is quartile deviation? If you divide this range by 2 or divide this range into 2 equal parts, it will become quartile deviation, which is represented by Q. And this quartile deviation is also known as the semi-interquartile range. So this is so you must able to differentiate between interquartile range and semi-interquartile range. Interquartile range is, again I am telling, Q3 minus Q1, whereas semi-interquartile range is half of that range. Whereas Garrett defines the quartile deviation or Q is half the scale distance between 75th and 25th percent is in a frequency distribution. Means there is a distribution. And it says the same thing. The quartile 3 is what quartile 3 indicates. It indicates the 75th percentile or percentage of frequencies, 75% of the frequencies. Whereas Q1, it represents the 25% of the frequencies. So difference between 75th and 25th percent, and divide that by 2. That is the quartile deviation. Again, one more definition I'll cover in this particular video. That is as per the J.P. Guilford. He said that the semi-interquartile range, remember, he is using word semi-interquartile range, means half of the Q3 minus Q1 is the one half the range of middle 50% of the cases. So he is talking entirely different way. He is telling that one half the range of the middle 50% of the cases, because there is a Q3 and there is a Q1. So what is Q3? Q3 is the topmost, uppermost limit of the 50% of the data. For that explanation, I'll take you to the previous slide. See, this is the previous slide. As per the Guilford said that this is the 75th percent and this is the 25%. So this is the uppermost limit of the middle 50% of the data. This is middle 50%. And this is the lowermost limit of the middle 50% of the data. So if you want to calculate the range of the middle 50% data, so what you have to do is you have to differentiate, you have to subtract the lowest lowest data from the highest value data. So that will come as your range. And if you divide that range by 2, certainly that will come as a quartile deviation. So why I discussed all these three definitions? These three definitions talks about the same thing from the different perspective. So I think, and I suppose, I am confident that now you are clear with what is quartile deviation. Now let us explain it. Though I explained it through the meaning and definition also. So this way we have three quartiles. That is Q1, Q2 and Q3. What is Q1? It is the midpoint of lowest 50% of data and also known as the lowest quartile or the first quartile. Remember, it is the midpoint of the lowest 50% of the data that I told you. No? Q2, it is the median of the whole data or the middle point of the given data set and also known as the second quartile. What is the Q3? It is the midpoint of the highest 50% of the data above the median. That is the midpoint above the median and also known as the highest quartile or the third quartile. Then comes the quartile measures the dispersion of the score above and below the median by dividing the entire data set into 4 equal groups. So dear friends, all about quartile deviation, its meaning, definition and little bit explanation. So introductory part, because introduction is very, very important. I explained it, I have given meaning to it and I defined it. So any data set that meets the assumptions of normal distribution tends to have maximum number of values in the middle. If you remember the NPC, normal probability curve, you will find the maximum 68% of the values in normal probability distribution are concentrated in the middle. So this is the same thing here. It's a kind of quartile deviation is a kind of half of the range of middle 50% data and also known as the semi-interquartile range I told you earlier. Quartile deviation is absolute measure of dispersion of the central or middle portion of the data set. So quartile deviation is purely the measure of the dispersion of the 50% central or middle 50% of the data set. That means quartile deviation talks about the only central part of the data set. So you must note here, very important note for the students and for the individuals who are interested in the statistics. The students must understand the difference between quartile and quarter. Quartile is a point on a data set, whereas a quarter is 1/4 part of the data set. So you can understand in different perspective. You can be in a quarter, whereas but you have to be at a quartile. You can keep yourself, you can accommodate yourself inside a quarter, but you have to be at the quartile. You cannot accommodate inside a quartile. So this is a major difference the students need to understand between quartile and quarter. So you should not confuse between that. Quartile is a point on a data set, where the quarter is a 1/4 part of that data set. What are the quartile characteristics of quartile deviation or QD? First, median is the base of quartile deviation, because we calculate three medians. One is the median of the whole data. Then second, the quartile 1 is the median of the lowest 50% of the data, whereas quartile 3 is the median of the highest 50% of the data. So you must understand, median is the base of the quartile deviation. The second important characteristics, quartile deviation is not affected with extreme values or outliers, because it just talks about the 50% of the data, middle 50% of the data. So the outliers, the extreme values can be lowest or highest, but quartile deviation doesn't consider these values. So it's a very important characteristics. It doesn't have impact of outliers or the extreme values. The third characteristic one, in a symmetrical distribution. Symmetrical distribution means that distribution that follows the normal distribution, assumptions of the normal distribution. Q1 and Q3, that is quartile 1 and quartile 3, are at equal distance from the median. It's a very important characteristic as far as statistics is concerned. It means median minus Q1 is always equal to Q3 minus median. You must understand this point. Means there is, if the data is a symmetrical one, so then Q1 and Q3 are equidistant from the median of the data. Then comes the fourth characteristics. Quartile deviation is the best measure of variability for which type of data? For data that have open-ended distribution. So what is open-ended distribution? Open-ended distribution means where the highest class or the lowest class doesn't have their highest limit. For example, we have a limits, that is less than or equal to 10, then 11 to 20, then 21 to 30, then 31 to 40, 41 to 50, and the next highest limit is above 50, 50 or equal or above. So that is open-ended. That distribution that is open-ended, if you want to measure the dispersion of such a distribution, the only measure is the quartile deviation, because just refer to the second characteristics, because it doesn't consider the extreme values. So for that reason, quartile deviation is the best and the only measure for the data which has open-ended. The fifth characteristics, quartiles are 3 points on the distribution that divide the distribution into 4 quarters or equal parts that can be said. Then the sixth characteristics, the quartile 1 and quartile 3 are lower and upper limits of the middle 50% of distribution, which I told you earlier. Then the seventh, it is the index of score density at the middle of the distribution. If you find a quartile deviation value, the quartile deviation, that value indicates the score density at the middle of the distribution. It's a very good indicator or index. Then the larger the variability in the distribution, the larger the value of the Q, and vice versa. This is a very important point here. Means if the data set has higher variability, particularly in the middle 50% of the data, in that case, the value of the Q will be certainly going to be higher, and vice versa too. Then in normal distribution, quartile deviation is also known as the probability error, or called as a PE. So sometimes you may be asked objective type questions pertaining to this point. So what is the probability error as far as the normal distribution is concerned? So you must say it's a quartile deviation. This deviation means half of the range of the 50% of the middle 50% of the data. So it is also known as the probability error. So dear friends, I talked about you the meaning, definition, introductory part, explained you. Then we talked about some 9 characteristics of the quartile deviation. Now let us engage in the computation, how we must compute the quartile deviation. First, we'll go with the ungrouped data. So in this example, I have taken as a hypothetical data. First case scenario, first is the ungrouped data. In that ungrouped data too, we have two scenarios, whether the data is in odd numbers or in the even numbers. So first we will calculate will compute the quartile deviation for the ungrouped data, and in the case when the data is in the odd numbers. So for example, this is our hypothetical data. We have 11 values here: 12, 54, 32, 51, 24, 60, 21, 44, 31, 48 and 50. If there is a question like this, so first step, what is the first step? Is the arrange the raw data in ascending order. The first step, as you have done in the median, in the case of median. Here also we are calculating median only. So therefore I have arranged for you first 12, 21, 24, 31, 32, 44, 48, 50, 51, 54, 60. It's in ascending order. What else to do now? Step 2, find out the Q1. How to find out that? Go to the median. So the formula for Q1 is the n plus 1 divided by 4. Now in the median we divide it by the 2, but because we are calculating the quartile 1, that is the median of the lowest 50% of the data. So for that we have to calculate the n plus 1 divided by 4. The value, that is the n plus 1 fourth position in the order distribution. Therefore what is n? 11 plus 1, it will be 12 divided by 4. Now answer will be 3. So here you must focus your mind, pay your attention dear friends. 3 is not the quartile 1. Third position, the value that is placed at the third position starting from the lowest value will be the value of the Q1. So in our case, the first value is 12, second 21, and the third one is the 24. Therefore, the quartile 1 is the 24. It's very simple, isn't it? Then we have calculated the Q1. Now we'll go for the calculation of the Q3. For that same case, find out the Q3. This is the step 3. For that reason, only one difference is, that is now n plus 1 multiplied by 3 divided by the fourth position in the order distribution. What is n? Yes, you're right, 11. Plus 1, 12. Okay, then 12 multiplied by 3, because we have to find out the median of the upper 50% of the data. So you have to 3/4, 75%. So 3/4 means 12 multiplied by 3. It is 36 divided by 4, 9. So again I am reminding you, 9 is not the Q3. It is the value in the order distribution which is placed at the 9th position will be considered as the Q3. So you must calculate. This is your order distribution: 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's a one. I missed one data. So we are that is. But at the 9th position, let us move to the previous slide. In this slide, if you calculate 1, 2, 3, 4, 5, 6, 7, 8, and 9, this is the 51. 51 is the, you say, the score point which is placed at the 9th position. My dear friends, so Q3 is 51. And the last and important step is the find out the semi-quartile range, quartile deviation, or Q, which I told you earlier. Q3 minus Q1. Further tell me. Yes, you are right. That is divided by 2. Q3 minus Q1 will be your interquartile range. And whereas if you divide that interquartile range into 2 parts, that will become your quartile deviation or the semi-quartile range. So Q3 was 51. Q1 was 24. So 51 minus 24 is 27, and if you divide by 2, it will 13.5. So my dear friends, for the data set and group data which have odd values, and that for our hypothetical data, our quartile deviation is the 13.5. This is simplest one. Now we'll go to the second case scenario for ungrouped data, but if the data is in even numbers, so it requires little bit two more calculations. So here, so data set have now this time we have 10 values. So first step is arrange this raw data in ascending order. See, I have arranged for you. Getting my points? Now, step 2, find out the Q1. So how to find out the Q1 is same case, n plus 1 is the 4, that is the position in the order distribution. So this time n is 10 plus 1 11. If you divide 11 by 4, your answer will be 2.75th position. So here comes the little bit difference between when the data is in even number and the odd number. So you have to find out the 75th position in the ordered distribution or ordered data set. So how to do that? It's a very simple one. First was the what you will go for the second observation. With the second observation, you know 21. See, this is the second is 21 plus 0.75 because it is 2.75 position. So in that case, so you will go for the third observation minus 21, second observation. So that is third observation, 24 minus 21 is the second observation, and you multiply difference of the third and the second observation with the 75, that is 1.5, and if you add to the second value, that answer will be your Q1, that is your 22.5 will be Q1 for the when the data set is in the even number. Now you will calculate the Q1. Similarly, we will be calculating the Q3 too. So this is your data set which is order arranged in the ascending order. Now step 3, find out the Q3, same case n plus 1 multiplied by 3 by 4th position in the order distribution. Now you know n plus 1 by 4 is, you know, n is 10, 1 is and 10 plus 1 11, 11 multiplied by 3 33 divided by 4 is the 8.25th position. Again I am reminding you 8.25 is not your Q3. The value in the order distribution which falls at the 8.25th position will be your Q3. How to calculate? First, find out the 8th position in this first, second, third, fourth, fifth, sixth, seventh, and 8th. So 8th position is 51. Then plus 0.25 because it is there 0.25, 25th observation. So that has to be 9th observation, that is 54, minus 8th observation, that is 51. That the difference is the 3 multiplied 3 with the 0.25 multiplied with 0.25, the answer will be, you know, 0.75. So 51 plus 0.75 will be your Q3, that is 51.75. Now the last step is the find out the semi-quartile range or QD or Q1. So what is that? Q3 minus Q1 divided by 2. Q3 is 51.75. What was our Q1? 22.5. If you differentiate that, that is answer, that is 51.75 minus 22.5, that is 29.25, and if you divide by 2 it will be 14.625. So quartile deviation for our hypothetical data when our data is in even numbers, our answer will be 14.625. I think you could get my point. Calculation of quartile deviation for the ungrouped data, and there are two cases in that. That's when the data is in the odd numbers and the data is in the even numbers. Now we'll be calculating the quartile deviation for the group data or the group data, and this time we have a table in the form of hypothetical data. So first, you know, group data, the data has been converted into class intervals, then that your score has been to convert to frequency, and I have calculated the cumulative frequency. So you know what is cumulative frequency? Cumulative frequency means adding the frequencies as you move to the next higher class. So first one is the 2, the next cumulative frequency will be 8 plus 2 10, 10 plus 6 is 16, 16 plus 12 is 38, 28, 28 plus 7 35, 35 plus 6 is 41, similarly 45, 48, 49 and 50. So in this also, step 1 is for calculating the Q1, find out the n by 4. N here is the total number of frequencies. That is the, you can see here, it is 50. So 50 by 4 is equal to 12.5. Therefore, we must here consider in mind that we have to find out the 12.5. We will look into the cumulative frequency column and we must find out the 12 point, where 12.5 lies. So 12.5 lies in this. It is greater than 10 but is less than this class interval. This means your quartile 1 lies in this class interval, that is 2024. Clear? Now, next, step 2, find out the Q1. The formula for Q1 is little bit complex in context of the formula that we use in the for the ungrouped data, but it's the simplest one. So this is the formula: L plus I into n by 4 minus fc bracket close whole divided by the fq. Now what these symbols indicate? Now let me tell you what is the L. L is the exact lower limit of the interval in which the quartile falls. You know, quartile falls, the 12.5 falls in this class interval. So exact lower limit of this class interval is 19.5. So getting my point, that is L. I means the size of the class interval, means 10 and 14, 15 and 19, difference between these, that is we have 5. That is I is the 5, size of the class interval. Then you know FC, cumulative frequency. Now this is the trick here. The cumulative frequency of the class interval, of the previous class interval in which the your quartile 1 falls. Quartile 1 falls in the this class interval 2024. So while calculating the Q1, we'll consider the cumulative frequency of the previous class, that is we'll consider the 10, not the 16. So this is the important point we have to remember in our mind while calculating the Q1. Then what is FQ? FQ means the frequency of the class interval containing the quartile. Now this time frequency, this is 6. I'm not talking about the cumulative frequency this time. This is the frequency of the class interval that contains the quartile. And what is n? N is the total number or the sum of frequency, that is 50. Now you can easily calculate the and put your substitute your values in this formula. So I'll show you that also. Now calculation. Now L you know, that is 19.5 exact lower limit of the class interval in which the your quartile Q1 falls. Second, that is 19.5. I you know, difference between the highest and the lowest class, that is the size of the class interval. FC is the follow, that is cumulative frequency. F is the frequency and N is the 50. Now if we substitute the values and calculate the Q1, it will look like that. 19.5 plus 5, 50 by 4 minus 10 whole divided by the 6. Then in the next, if we simplify it, this will be the case. And finally 19.5 plus 5 into 2.5 divided by 6. Finally 19.5 plus 12.5 divided by 6, and it is 32 by 6. So first Q1 of the group data is 5.33. So dear friends, here important point is you must remember the formula for that. If you want to study how that formula is derived, there is J.P. Guilford book or Garrett's book. In that it is clearly mentioned why we use all these things, why cumulative frequency of the previous class, why the frequency of that particular class, why we calculate the object exact lower limits and again upper limits of the class intervals and all these things. So I'm not going to discuss all this here because video will be going to be too long. So we have to calculate one more thing, that is Q3. Q3 is the same as the Q1. Don't worry, I'll let you know how to calculate the Q3. So this is the step 3. Here there is a change. In Q1 we calculated n by 4. So here we'll calculate 3n by 4. So 3n by 4 means, and you know 50 total of the frequencies. So it is 50 into 3, it comes to 150 divided by the 4, that is the 37.5. So now we have to find out the class interval in which Q3 falls. In the next slide, I will show you this, and that is the class interval 35 to 39th class interval, where you will find that Q3 falls 37.5. So now we have to find the Q3, and the formula is as exactly similar to the Q1 except one change. Here there was no 3, but now in this Q3 we have to introduce the 3 because we have to calculate the 75%. So formula is similar: L plus I 3n by 4 minus Fc divided by the Fq. Now you know what is L. Okay, does it require on my part to explain you L? Okay, I'll explain you the L. So, dear friends, you know we have calculated 3n by 4. That answer was 37.5. So you know 37.5 falls in this class interval because this is less. 35 is less than 37.5. So that your quartile 3 falls in this class interval 35.9. So, my dear friends, the exact lower limit in which the Q3 falls is the 34.5. I is the size of the class interval, that is 5. The cumulative frequency is the 35. The cumulative frequency of the previous class to the class in which the Q3 or the quartile 3 falls, that is 35. Here you can see this cumulative frequency, because you know the Q3 falls in this class. The cumulative frequency of the previous class, that is 35. Whereas FQ, frequency of the same class in which the Q3 falls, that is 6. You know here it is. So now and you know n is equal to 50. So if you substitute the values, so this way our answer will be 34.5 plus 5, then 3 into 50 divided by 4 minus 35. So it will be, if you calculate this way, the answer will be 7.83. What is 7.83? This will be your Q3. Now it is very simple. The last step is very simplest one. If you substitute the values calculated in the previous slides for the values of Q1 and Q3, so you know Q3 is 7.83 and Q1 is equal to 5.33. So 7.83 minus 5.33, the output will be 2.5. So here 2.5 is the interquartile range of this group data which I have shown you in the tables. If you want to calculate the quartile deviation, you have to divide 2.5 with 2. That is, answer will be 1.25. That is the semi interquartile range, or you can call as a quartile deviation. So my dear friends, our quartile deviation of our hypothetical data is 1.25. Means this represents the dispersion or the variability of the middle 50% of the data. So once again, I will let you know, we have discussed the meaning, definition. I explained in the quartile 3 quarters. So you must differentiate between what is different between quartile and quarters. Quartiles are the points on a data set, where the quarters are the 1/4 part of the data set. Then we discuss some characteristics, important characteristics, which I told you. Median is the base of the quartile deviation, calculation of the quartile deviation. And quartile deviation is the dispersion or the variability of the 50%, middle 50% of the distribution. Then we calculated the quartile deviation for n group data. We have two case scenarios in n group data, whether the data is in even numbers or in the odd numbers. And then we calculated the quartile deviation for the group data. One important point, application or use of the quartile deviation. So the major application use of the quartile deviation is where the data set has open-ended, means where the distribution is open-ended. There, if you want to calculate the variability or dispersion of that, the only measure available in the statistical techniques or tools is the quartile deviation. So my dear friends, these are my references. You can cross-check them. If you want to study some more, J.P. Guilford book I referred, Garrett book, Levin Fox and other books also I referred various online material. So next we will be discussing very important point, that is standard deviation. By the time, if you want to make any comment, you want to say something, if you like this video, kindly mention in my comment box, or you can write through email, that is vermasudhit@yahoo.com. Further, if you like it, share with your friends, and if you dislike it or you want to say something to me regarding this my video, kindly post your comments through comment box or my email. I'll always wait for your comments, whether they are appreciative or they are critical. My dear friends, thanks for watching this video.